All right. We want to look at building section, and as you know that we have talked about the building plan, how you can convert a line plan to a solid plan. We have done that, and then we have also worked on how you can construct the front elevation of a building when you are given the plan. Now, what we want to do now is to construct the building section. As you can see here, this is a building plan, power plan, which is a live plan. And if you look very well, you will see a cutting plane XX. This is a cutting plane XX, as you can see it here. And whenever we are to construct the building section, we have to look at the components of the building that the cutting plane cuts. If you look at this building plan, the cutting plane cut this wall, and not only the wall here, it cut the window, as you can see it here. And coming down here, it cut this wall here, and coming down here, it cut this door. All right. Now, this wall that we have here, on which the window is mounted, has its own foundation. This wall has its own foundation, and the wall on which this door is mounted has its own foundation. So we have to produce 3 foundations. Now, by the time we cut this building plan or the building and we remove these parts, there are things that we see. Let's assume that you are standing here and this part has been removed. So what will you see here? So for me, if I'm looking at it after this part has been removed and I'm standing here, I will see this door. I will see this door, and then I will see this door here. Then this will be a wall. This will be a wall. So those are the things that we need to put in the building section. Very, very important. Now, having explained this, let's look at the specifications for building section. As you can see on the board, number 1 is foundation. And we are told that the foundation has dimensions of 800 by 225 millimeters, and it happens to be a strip foundation, and the foundation is at a depth of 700 below the ground level. That's number 1. Number 2, we have the walls. As we are told here that all walls are 225 sandcrete hollow blocks with 13 mortar rendering on both sides. So we'll come to that later, but I need to explain this. Then the next is we have doors. We have double door. So we have double door here. So double door, the height is, this is the height, as I've explained before. So this is the height. So the height is 2,100 by 1,800 by 30. So 2,100 is the height. So the wideness is 1,800 and the thickness is 38 millimeters. So it happens to be a panel wooden in 100 by 50 timber frame. So that is the dimension of the frame. Dimension of the window is 2,100 by 1,800 by 30 millimeters thickness. Then we have that is for the single door. This is for the single door. So this is single door, single door, single door, single door, single door. So we have single doors there. Then we have this to be 2,100 by 900 by 38. So it happens to be a flush wooden door in 100 by 50 timber frame. Then we come to floor. So in the floor, what we have in the floor, we have 300 hardcore, 150 concrete slab, 25 mortar screed, floor to ceiling height space is 3,100. Then we come to the lintel. So the lintel is 225 by 225 reinforced concrete. Then the roof, it happens to be a gable roof with corrugated aluminum sheets. Pitch angle is 15 degrees. East projection is 300. Timber rafter 150 by 50 at 100 centers. Purlins 750 by 50 at 900 centers. And ceiling joist is 50 by 50 at 600 centers. And we are asked to assume any suitable dimensions where necessary. Very, very important. Then let's come to the question here. As we have here, that we are to draw to a scale of 1:50 the sectional elevation on plane XX. So the scale that we are using here is 1:50. That means we are to divide each dimension by 50 millimeters. Each dimension will be divided by 50. So that's what we are going to do. So very, very important. All right. Having explained the specifications, because of the limited space that we have on this board, I'm going to clean this. I will clean this, and I will clean this. So I've written the specification down on a paper with the divisions that I've done. So I've divided each dimension that we are to make use of by 50 by 50 as we have in the scale. So I will rub this off and I will be calling what we are going to use. I believe that you have all this in mind. So let's go. So I'm going to rub this off. I'm rubbing this off from here, so that we can have enough space. So we need enough space so that we can be able to see the diagram clearly and boldly. Now, the first thing that we need to do is that whenever you want to build a house, you start with the foundation. So you don't build a house from the roof, so you build the house from the foundation. As you know, so before you can get to university, you have to start from primary school. That is the foundation. The foundation has to be laid. So the same applies to the construction of a building. So the first thing that I need to do is to draw the ground line. That is the first thing that you are going to do. So you draw the ground line. So we need to manage the space. So you draw the ground line like this. So this is a ground line, okay, or ground level. So we call it ground level. So the next thing that I need to do is that, we have this wall. So we have this wall, and we have what? We have this wall. So the first thing is we are going to position this wall. We are going to position this wall. So all these are external walls, as I've explained before when we did that of the building plan. So we position this wall. So just draw a vertical line like this. So the distance from here to here is 3,200. 3,200 by 50 will give us 64. So you take a measurement of 64 millimeters. So let's say from here to here, or let me stop it here. So this should be okay. Let me put it somewhere here. So 64 millimeters. So you draw a vertical line like this. So next, we have what? So the distance of this wall from here to here is 4,000. So 4,000 by 50 will give us 80. So take a measurement of 80 from here to here. So let's stop it here. So here we have what? We have 80. So then you draw a vertical line. So don't forget that all these are external part of the walls. They are external part of the walls. Now let's take the thickness of the wall as we have here. So 225, that is the hollow block. Then we have 13 mortar screed on both sides. So 13 plus 13 will give us 26. So we add 26 to 225, and then that will give us 251. So 251 by 50, that gives us approximately 5 millimeters. So what you need to do is to take a measurement of 5 millimeters from here to here. Then from here to here, take 5 millimeters. And then you come here, take 5 millimeters inward like this. Then you draw vertical lines. So I still need to rub off some things so that you can see it clearly. So here we also draw vertical line here like this, and then here we also draw a vertical line. All right, so having done this, so the next thing is, let's go to where we have the foundation. So in the foundation, we have the foundation is, so if you divide 800 by 50, 225 by 50, that will give us, this will give us 16. 800 by 50 is 16, and 225 by 50 will give us, that will give us 4.5, which is approximately 5. Let's make it 5 millimeters. But we are told here that the strip foundation, the foundation is 700 below the ground level. So what you need to do is that, so 700 by 50, that gives us 14. So take a measurement of 14 millimeters down. So let's say this is where we have 14 millimeters. So this is 14 millimeters. So from here to here, this is 14 millimeters. So draw horizontal line like this. So draw horizontal line. So draw horizontal line. So let it come to this side. All right. So now, so the length, the length is 16. So 16. So from here to here we have 5. So if we take 5 out of 16, so that will give us that is 11. So take 5.5. 5.5. Here we have 5.5. So we are dividing 11 by 2. That's what, that is 5.5. You come here also 5.5 to this side, and then here 5.5 to this side. Then from here 5.5, and from here 5.5, and you produce vertical line like this. So vertical line. Okay, there's a mistake that I've made here, so I need to correct it. So distance from here to the end of the foundation is 14 millimeters. Please take note of that. Distance from the ground level to the bottom of the foundation is 14 millimeters. It's 14 millimeters. So that means from here to here is 14 millimeters. Please take note of that. Take note of that. So, all right. So I draw this. All right. So and I also draw this. All right. So distance from here to here, from this point to this point, is 225 by 50, and that gives us 5, approximately 5. So distance from here to here is 5 millimeters. So take note of that. So now, so we made this. So this is a concrete strip foundation. So this is how I usually do it. So that this, the circles that I put there, they stand for the gravel, and all this, they stand for cement. So cement. So because of time, and then so you put this like this, and then all right. So the next thing that we are going to do is to put the, so we come to the floor. We come to the floor. So we come to the floor. So this is not needed. So this line is not needed, and this line is not needed. So we come to the floor. So in the floor, we have what? We have hardcore. So hardcore that we are given. So we have divided, I've divided the dimension of the hardcore by 50 because we are given 300. 300 by 50 gives us 6. So from here, so you take 6 mm down, that's 6 millimeters, take 6 millimeters down and draw a horizontal line like this. So draw a horizontal line. So the horizontal line goes like this. So draw a horizontal line. So it goes like this. So now, so here we have what? We have the hardcore. So here we have the hardcore. So I need to clean this. So here we have the hardcore. So for the hardcore, this is the symbol for hardcore. So this is symbol for the hardcore. So you do it like this. Okay. So this is the symbol for the hardcore. So you do it like this. Then under the hardcore we have sand. So we have sand. So we have sand under the hardcore. So or we call it earth. So it's normally called, we usually call it earth. So this is the symbol for earth. That is the sand. Alright, so on the hardcore, so we have what? We have the concrete slab. So the concrete slab are divided its dimension by 50, and that is 3 millimeters. So you take a measurement of 3 millimeters up, and you draw a horizontal line. This is how you draw it. So the concrete slab will not cover the wall. So okay, so that is for the concrete slab. So we have, as we did for the foundation, so you do like this. Alright, so that's for the concrete slab. So next we have what? We have the mortar screed. So the mortar screed is the dimension for that. After I divided it by 50, it's 25. So 25 by 50 gives us 0.5. So just approximate it to 1 millimeter and draw a horizontal line. So I will just draw this like this for the mortar screed. So it goes like this. For the mortar screed is on the concrete slab. So it's on the concrete slab. Mortar screed is on the concrete slab. So this is how you draw it, like this. Okay. So after all this, after doing this, so the next thing that we are going to do is to take a measurement for the ceiling height space. So the measurement for the ceiling height space, after I divided by 50, is 62. So you come here from here to here, you may take a measurement of 62 millimeters up here, and you draw a horizontal line. So draw a horizontal line. So draw it like this, and draw it to this side. Okay. So let's take a measurement, because we are going to put ceiling joist. So we are going to put ceiling joist. Just take a measurement of something like 3 millimeters. So take it up like this, like 3 millimeters. So you take it here. Alright, so after that, we are going to put the tie beam on this. So we are going to put the tie beam on this. So I need to clean this. So we are going to put the tie beam. I'm putting the tie beam on this one. So tie beam. So you put the tie beam on it. Just take a measurement of. It is not mentioned in the specification, but I know from experience that tie beam has to be there. So just take a measurement of 3 to 4 millimeters and draw a horizontal line like this. Now after drawing this horizontal line, so just produce this partially up, produce this partially up. So in the specification, we are given the pitch angle to be 15 degrees. The pitch angle is 15 degrees. So put your protractor here put your protractor here and take a measurement of 15 degrees. So let's say it touch here. So put it here, you have the same thing. You have the same thing. So what you just need to do now is that from here, so you produce a line slanting like this, and then from here you also do the same. So produce a slanting line like this at angle 15 degrees. At angle 15 degrees. Alright, so after doing this, so having done this, so the next thing that you need to do is that, so we have what? We have the rafter. So the rafter will be placed here. So the rafter has its own thickness. So just take a measurement of 3 millimeters. Take measurement of 3 millimeters. Just look at the way I'm going to do it. Most of the specifications that we are given, they are not really useful. They are not really useful. So we need to do some things ourselves. So take a measurement of 3 millimeters from here and draw a line like this. So that will stand as the rafter. So draw it like this, and then do the same here. So do the same here, and you have this. Alright, so having done this, the next thing is we put the purlin. So purlin will be laid here. So be laid here. So we are nailing the roofing sheet on it. So we put the purlin. So the space here, I'm not taking any space. So, but in the question it will mention, but sometimes it's not really work. So just make sure you are able to position it, and the space should be equal. Just try as much as possible to position them. So to position them well. So you need to try to do that. So just make sure you position them well. Alright, so then the next thing I'm going to put here is the roofing sheet. So the roofing sheet will be laid on the purlin. So as you can see it here. Now also produce it to this side like this. So the roofing sheet has its own thickness. Just take like 1 mm. So take like 1 mm or 2 mm and draw. And also, so you draw this. Alright, so so the next thing is we put the ridge cap. So the ridge cap goes like this. So the ridge cap goes like this. So this is the ridge cap. Then the next thing is we put the king post. So king post. So just take a measurement, maybe 4 millimeters or 33 millimeters. So draw this. So this is the king post. Then you position the struts or the queen post. So position them like this. So you do the same thing on this side. Position the struts or the queen post. So and then so now put the struts. So like this. Okay. So as we are told that this type of roof is a gable roof. So this is what you will see when the section is drawn. So you also do the same thing here. Okay. Alright, so here also, So you also do the same. Alright, so we are done with that part. So the next thing is, so I put the ceiling joist here. So this is the ceiling joist. So this is how we show the ceiling joist. Then I'm going to put the work plate. I'm going to put the work plate. So the work plate will be here. So this is the work plate. So this is the symbol for work plate. So that's the symbol for work plate. Then I will also put work plate here. So I put the work plate here. So this is the symbol for work plate. So next, as we are looking at what we have here, alright, so when we call this, as I said, that we are going to see this door and also we see this door. And then the cutting plane cut this window. So this window, so we have this window here. So just come down a little bit, and then every window has its own lintel. So we have a lintel here. So as we have in the specification, the lintel is of dimensions of 225 by 225. So if you divide 225 by 50, it will give you approximately 5 millimeters. So take 5 millimeters from here to here is already 5 millimeters. Just take 5 millimeters down. So take 5 millimeters down. So this is a reinforced, lintel. So just put this. So this is a lintel. And also, we also have a lintel here. We have a lintel on top of the door. So just come down. So any measurement that you take from here to here. So take it from here to here and put the lintel here. The same dimension. 225 by 225 divided by 50. So whatever you get, that's what you need to do. That's 5, 5. It's in a square form. It's usually in a square form. So you have the lintel here. Then for the window, so as we have, so for the window, so in the specification for the window, so we have what we have the height of the window. The height of the window, okay, I didn't put that here. I think the height of the window is something like maybe 900. So divide 900 by 50, whatever you get, so just take it from here to here. From here to here. And then, so this is for the window. So we have this for the window. So, and then we have what? We have this door. So this door is here. So just take 21 millimeters down from here. So that, okay, that's 2100. 2100 by 50. Whatever you get, you take it down from here. And here we have what? We have the thickness of the door. Thickness of the door. So this is wooden, as we are told. So the frame is made of what? The door is made of wood. So the next thing that we have here is to show that this is a wall. So this is a wall. Okay. So we have to show that this is a wall. So I'm showing it there, that here is a wall. All right. Okay, so I also need to show it here that this is a wall. All right, so the next thing I'm going to show here, we have these two doors. So we need to draw them here. So we draw the doors. The door has a frame, and the type of door that we have here, we are told that's a flush door. So just put something like this. Okay, so we also have another door here. So at the back, so the same dimension. So the same dimension. So put this. Alright, so then what else do we have? We also see this door. You see this door. So this door is positioned somewhere here. It's also a flush door. It's also a flush jaw. So we have it here. Alright, so we have this. So having done this, I think we have tried. So we have tried. So this is a ceiling joist. So you need to label. So ceiling joist. So this is a ceiling joist. You need to label. And then this is ridge cap. We have purlin. We have the iron sheet. And then this one, this is a rafter. This is a tie beam. We have the warp plate. And then, so these are the doors. We have the lintel. And then we have the mortar screed. We have the concrete slab. We have the hard core. We have the head. So this is called foundation footing. This thing is called foundation footing. So this is the foundation. So this is the foundation. So this is foundation. So take note of that. And this is foundation footing. So we call this foundation footing. So in case you are asked to put the blinding, so the foundation footing is laid upon the blinding. So though it's not mentioned in this question that I'm solving, it's not mentioned there, but in case you are asked to put the foundation footing on a blinding, so this is what you just need to do. So the foundation, the blinding is made with a mixture of sand and cement. So this is called blinding. This is called blinding. So take note of this. So I can see that we have tried. So you just need to practice this. So once you practice, you will master it. You master it. So it's something very, very simple. So building drawing is not hard. So what you just need to do is to practice. Don't forget, as I said when we started, that I framed this building plan myself. So I also framed this myself. I didn't copy it from anywhere. I just drew it myself, because whenever I want to teach this part of building drawing, I usually start with something simple. So if you can get the simple one, by the time you are given a question, by the time I give you a question, it won't be hard for you. So this thing is known as soffit. So we call this soffit. And distance from here to here. Distance from here to here. So distance from here to here is known as eaves projection. So we call it eaves projection. So it is given in the question as 600. So we call it eaves projection. So take note of that. So we call it eaves projection. So take note of that. So I really appreciate you. Keep on practicing. Keep on practicing. Technical drawing is not hard. All you need to do is to practice. If you can practice, it won't be difficult for you. Thank you for listening. Subscribe to my channel if you have not subscribed, and share this video with friends who are technical drawing students. And I really appreciate you. God bless you.